Hello everyone and welcome back to our course. In this lecture, we're going to learn how we can find relationships between our numerical features. Finding relationships between features is a very common step of data science projects and also machine learning projects because you can learn correlation between different features and which features actually matter. Alright, so let's create a new code cell where we will get started. We're going to take our data frame and let's use the plot function to create a plot. And I am going to use the scatter function of that plot module to create a scatter plot. Here I can pass in an X and a Y. So I am going to choose my Y to be my sale price because that's very commonly used as the target variable. Now X can be anything from my numerical features except sale price. So let's choose lot area, how about? All right, then I'll go back to that code cell that I just had and I'll pass in that lot area column as my X. Then if I run that code cell, look at this. We can now see on the Y we have sale price and on the X we have lot area. And look at this. We can see that as lot area increases, our sale price usually increases as well. Except for we did have a few outliers where sale price did not increase. We can also create another type of plot with the help of a new library known as the Seaborn library. So let's first off import our Seaborn library. So I'm going to make a new code cell here and I'm going to import Seaborn because the Seaborn library is going to allow us to build more plots than PyPlot and Matplotlib can handle. All right, so I'm going to import that library, then I'm going to call seaborn.jointPlot. Let's create a joint plot. I'm going to pass in the same X of lot area and the same Y of sale price. I'm also going to pass in a data argument, and this is going to be our data frame. Then I can pass in a joint keyword, and I'm going to use the S should equal 10. Now we'll get something very interesting when we run this code cell. I'll just make sure you do have a comma between all the arguments. We have a new type of graph that you may or may not have ever seen before. Okay, so we still have sale price versus lot area, but we also have histograms at the top and at the side of our graph. And we can see here the frequencies at which a sale price appeared and the frequencies at which a lot area appeared. So it's kind of like combining 2 into 1. Next, let's look at how we can compare all of our features at once. So I'm going to create a new code cell and I'm going to use Seaborn to create what's known as a pair plot. I'm going to pass in my data frame at my numerical features. And we have a lot of numerical features actually, so I'm just going to choose the first 4 with this :4. Then I'm going to pass in as well plot KWS, where S is going to equal 10. All right. And now I'm going to then run this code cell. And we're going to get a similar graph to what we had previously, but this time we're going to get actually multiple graphs. Look at that. So we now have multiple graphs because we are going through all of our numerical features. And this time we can see how all of our first 4 features compare to each other. So we can see here we have sale price versus sale price, then we have sale price versus lot area, sale price versus overall quality, and sale price versus overall condition. Then we have lot area versus sale price, lot area versus lot area versus overall quality, and lot area versus overall condition, and so on and so forth. We can also look at all of our features if we want. Let's see, how many numerical features did we even have? Let's look. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can actually get more of them. We can get all 8. I'm just going to change that 4 that we had into an 8 instead. Let's run that code cell now, and we'll get a much larger graph this time. So we'll just give it a minute for it to load because it has to create all of those graphs. We're going to get quite a few. And they also can be a bit small, so typically it's good to create subplots and just show a few at a time. So we're creating what's known as a pair plot from the Seaborn library. Okay, and when that finishes, we can then continue on. So this actually might take a while just because we have to create so many because we're going up to 8. So if Oh, there we go. There we go. Okay, actually finished now. Good. Okay, so here, look at that. We just have a much bigger graph now, so that's why it took longer, because now we're comparing all of our features against each other. And this is a great way to see the correlation and how features relate to each other. So feel free to look into every single one of these if you're interested, because you can get some very good insights from your data just by building a visualization like this. And it also helps you tell a better story, because you can easily provide a visualization that even the non-programmer can understand. All right, and we can also just get the first 4 and then show the last 4 with 4 colon. That will give you the last 4 if you don't want to do all 8 at once, but looking at all 8 is quite interesting as well. All right, and we can also make just a textual representation of the relationships. So for that, I'm going to take my data frame at my numerical features, and I'm going to use the core function. Make sure you have 1 O, 2 R's, then run that, and look at this. We can now see correlation between all of the features, and that's as a number. So if you have a value greater than 0, you have positive correlation. If you have a value negative, you have negative correlation. If you have a larger value, you have more correlation. For example, overall condition and overall condition, they have a 1-to-1 correlation because they're the same exact feature. So the closer the number is to 1, the higher the correlation there is. Note that you'll get a 1 if you are comparing the same feature against itself, because that's a 1-to-1 correlation. Something like a 0.8 correlation, that is quite high as well. So we can see that sale price and overall quality, they have a 0.8 correlation, which is quite a lot. So that means that if you have a higher quality house, it's more likely to be sold for a higher price. Whereas something like, look at this. Let's see, what else would not affect sale price? Well, 0.2, that is a very small correlation compared to overall quality. So that means that if your house has a higher lot area, you won't be guaranteed to sell it for a higher sale price. Then if you have negative correlation like age when sold, that means if you have a bigger age of your house, it actually has negative correlation, which means you'll sell it for even less. If you had a positive 0.5 here, then that would mean that if your age of the house was higher, then the selling price is higher, but that's not what we have. We actually have negative correlation. So look at that. We already get some very interesting results, and we can even sort them as well. So for that, I'm going to create a new code cell. I'm going to get my data frame at my numerical features, and I'm going to use the core function again. This time I'm going to only get the sale price column from this result, so this sale price column here, that first column. And I'm going to use sort values, the function to sort, and ascending I'll set equal to false, which means I'll get descending order. So now I get the columns or the features that have the highest correlation with sale price. Of course, number 1 is sale price itself, correlating with itself. Then we have overall quality and first floor square footage. So that means that the third highest correlation with sale price was first floor square footage. So you know that the bigger your first floor is, the higher your sale price will be. There is some correlation with that. Awesome, and that is already some powerful insights that we have gotten. All right, we can also create a very interesting visualization known as a heat map from all of these correlations. This is very commonly created, these heat maps, as part of the data analysis phase of either a data science project or a machine learning project. So let's do that. So what we're going to do is take the data frame at the numerical features.core again. This time we'll save the result as our correlations. And then we can use pyplot to create a plot out of that. So I'm going to use pyplot.subplots, and I'm going to set the figure size. Let's do something like, let's see, what value should we do? We could do any value really, like 10 by 10 to start off. Then we can use Seaborn to create what's known as a heat map. And we have to pass in the correlations for our heat map, followed by our axis. So the subplots function, this returns a figure and our axis. And I'm going to pass in here the AX argument as our axis. Then I'll run this function, and we're going to get a heat map. And look at this. So a heat map is an even easier way to visualize correlation, because it will tell you the color and the correlation. So we have negative 0.75 will be a black color. Positive 1 will be a beige color. So that's why we have beige running in diagonal in the middle of our heat map, because that's every column compared with itself. But then we can see if we look for this light orange, that means we have a high correlation, which is why we have that orange color at sale price versus overall quality. We also have that light beige or light orange color in the reverse of overall quality versus sale price. We then have a light orange color at sale price versus first floor square footage. Then if we look for something that is a black color, like age when sold versus year built, look at that. Those two, they obviously have negative correlation because age when sold is going to be negatively correlated with year built. And let's see, if we look for a dark purple, that will also tell us we have negative correlation. So overall condition has a negative correlation with year built, which makes sense because the older a year, the less the condition. So the greater the year in terms of, the age would be even better, the less the condition. So look at that. Heat maps are very commonly used because they provide a really quick and intuitive way to visualize correlations between features. And you need to know correlations between features to know what you can do with your data. All right, next up, we're going to look at how we can look at relationships between categorical features. So we're actually going to build slightly different plots for looking at how to find the relationships between categorical features. So join me in the next lecture where we will continue our project.